Hi dear students, we are starting to new chapter 3, analytic analysis of lines, and we are going to start with the topic distance between 2 points in coordinate plane. Finding the distance between 2 points, let's say A is equal to x1, y1, the coordinates of the A, and B is equal to x2, y2. Then the distance between these 2 points, it's going to be AB is equal to square root of x1 minus x2 square plus y2 minus y1 square, it's going to be. And here the explanation, also the graph of it. You know the coordinates of the points here. If it is x2 and y2, here x2 and y2 it's going to be, and the other one is x1 and y1 here. This is x1 and y1. Okay. With respect to, if you want to find this distance between them, if you want to find the distance these 2 points, you can make one right triangle here. You can use the help of this right triangle, and in this right triangle the distance of here, this 2 points, it's going to be, since the coordinates on the x-axis x2 and x2 minus x1, it's going to be here the coordinates of the y2 and y1, so the distance between them y2 minus y1 it has to be. With respect to this order, y2 minus y1 and x2 minus x1, and if this is the hypotenuse, then it's going to be x2 minus x1 square plus y2 minus y1 square is equal to d square, which means that d is equal to square root of x2 minus x1 square plus y2 minus y1 square, it has to be. Okay, let's solve this question, and the formula is here, that's why I'm not going to write one more time, but I have to mention what is x2 and y2 here. Actually, which one is x2, which one is x1, it is not important. Which one is y2, which one is y1 is not important. But of course, x1 and y1 should be together. So I can name also like this. I mean, which one is not important. I can name also like this here. Let's say this is x2, y2, and this one is x1, y1. I can name these two as it is written. So here, what it's going to be, x2 minus square root of AB is equal to the length of AB, square root of x2 minus x1, which is equal to 3 minus 2 square, plus, and y2 minus y1 square, 0 minus 3 square. Minus 3 square. So with respect to this one, we are going to find the AB as square root of 3 plus 2 square, which is equal to 3 plus 2 square, plus 0 plus 3 square, which is equal to 5 square here, square root of 5 square plus 3 square, which is equal to, AB is equal to root 25 plus 9, which is equal to, AB is equal to root 34, it has to be. If we continue with the other question here, it says like this. If A is the same distance with points B and C, find the value of A, which means that AC is equal to here, AC is equal to AB. AC is equal to AB, because A has same distance to C and B, which means that here, if I name AN points A and C, I'm going to get A like x1, y1, A is equal to x1, y1, and C is equal to x2, y2, which means that AC, it should be equal to square root of x2 minus x1 here, minus 2 minus A, minus 2 minus A square, plus 1 minus 2 square, 2 square. It has to be equal to square root of, it should be if you name like A is x1, y1, then B it should be x2, y2 in a B distance. So if I write this one here, B is x2, y2, so 3 minus a square, 3 minus a square, 4 minus 2 square plus 4 minus 2 square. It has to be. So, here minus 2 minus a can be written, you can get the minus parentheses, or if you want to get the square of this expression, a minus b parenthesis square, it should be equal to a square minus 2ab plus b square. So here the square of this expression, it's going to be equal to minus 2 square. Before then that one, I forget something here. Firstly, let me get rid of the square roots on both sides to solve this equation. To solve this equation, we should get the square of both sides to get rid of the square roots, which means that this is going to be equal to minus 2 minus a minus 2 minus a square minus a square, and 1 minus 2 square is equal to minus 1 square is equal to 3 minus a square plus 4 minus 2 square is equal to 2 square. It has to be here. I think it's good to take these are from here. Yes. This one here a bit away. I'm going to choose like this. This part. Yes, in this one, then let me change the color also here. Yes. Now let's continue with this part. Here a minus b square is equal to a square minus 2ab plus b square. So it is equal to minus 2 square. Minus 2 times a is equal to here, the b is equal to a, it becomes so minus 2 times a and plus a square plus 1, it's going to be here. And on the other side, 3 minus a square is equal to 9 minus 2 times 3 times a plus a square, it has to be, and plus 4 it should be. So here it's going to be equal to 4 plus minus 2 times minus 2, it's equal to 4a plus a square plus 1. On the other side it is going to be 9 minus 6a plus a square plus a. As you see, we can simplify a square from both sides here in addition form. So we have here, this one I think it should be 4. Yes. Then force also you can simplify from both sides. It is possible to simplify. We have 4 on both sides. This 4 and this 4 I simplify. And now we have the 9 minus 6a, 4a plus 1, which is equal to 4a plus 6a. It should be equal to 9 minus 1. 10a is equal to 8. A is equal to 8 over 10. It has to be a is equal to here 4 over 5. When you simplify both of them by 2, it's going to be, and this is the answer of the question. It has to be. Okay, here we have the third question, but before then that one I need to make this explanation here. Find the ordinate, it says. In coordinate plane, the value here for this value a and b, the coordinates a and b, it has 2 points on the coordinate plane, which is a on the x-axis, b is on the y-axis. You know this one from the coordinate plane. But the value a is called abscissa, x-coordinate or abscissa, y coordinate or ordinate. So the name of the x value in in the coordinate plane we can call as abscissa, and we can call as ordinate. So find out the ordinate means here find the y value. Here this is the ordinate it becomes. Okay, now we are going to find the, like this is the previous question. It is similar with the previous one, only the here the distances are not given. So PA, it should be equal to square root of, if you name this as x1 and y1, this is going to be x2 and y2, which is minus 4 minus 0 square, minus 4 minus 0 square is equal to 0 minus k square. And PB, if I write here, it's equal to PB is equal to 9 minus 0 square, 9 minus 0, because this time this is going to be x2, y2, and this is xy, y1, 9 minus 0 square plus 5 minus k square. It has to be. So since PA is equal to PB, we are going to name like this is square root of 4 minus 0, it's equal to obvious that minus 4 square plus minus k square is equal to minus k square is equal to square root of 9 square plus 5 minus k square. It has to be. So to solve this equation, first we should get rid of the parentheses here. This one and this one, if we get rid of the square, if we get the square of both sides, then it's going to be like here 4 minus 4 square plus minus k square is equal to 9 square plus 5 minus k square. It's going to be minus 4 square is equal to 16, minus k square is equal to k square, 9 square is equal to 81, and 5 minus k square is equal to 25 minus 10k plus k square. It's going to be, from the previous page I have written the a square minus b square, a minus b parenthesis square is equal to a square minus 2ab plus b square I have written, and this is 5 square, then minus 2 times 5 times k, which is 10k, and plus k square. It's going to be, as you see here also we have the we have again the k square on both sides, so we can simplify first the k squares from both sides, then we will have operation with the rest. What does it mean? We will send the 10k to this side. 10k is equal to 81 plus 25 minus 16. It's going to be here 25 minus 16, it's going to be equal to 9 plus 81. 10k is equal to 90, it should be. So 10k, if it's equal to 90, k is going to be equal to 9 here, 90 over 10, k is equal to 9, it has to be. Okay, this is the end of our lesson.